Hi guys, today we'll be talking to you about the inherent bias in the law enforcement technique known as predictive policing. Predictive policing is a method of crime forecasting that utilizes algorithms to analyze pre-existing crime data to predict where crime might occur, when, and by whom. Crime data can be sourced from crime mapping, geospatial prediction, or social media analysis. Predictive policing, slowly gaining traction as an objective tool available to police departments, has been subject to much scrutiny regarding bias in its analysis practices. Indeed, its use of geospatial data and previous arrest records based on location bring into question biased input data regarding socioeconomic status and race of residents in hotspot areas. The concept of environment and location as influential forces in crime gained traction in the 1970s with C. Ray Jeffrey's proposal of crime prevention through environmental design, or CPTED, and Oscar Newman's theory of defensible space. Jeffrey's conception of CPTED is rooted in B.F. Skinner's theory of behaviorism, which stressed enrichment or deprivation in the physical environment as having positive or negative impacts on the subject, in this case the offender's, behavior. Jeffrey proposed relatively simple but effective architectural and landscaping modifications that encourage observation of sidewalk areas, such as large windows and street lamps, as well as communication between neighbors regarding activity around the neighborhood via porches and sidewalks. In turn, these alterations were theorized to increase the visibility of crime activity in progress, which would encourage civilian reporting of said activity. Concurrently, Oscar Newman proposed the theory of defensible space in his 1972 book of the same name, which described a study into how architectural design influenced crime rates, specifically when comparing high crime rates in high-rise apartments versus low crime rates in low-level buildings with similar demographics. Both Jeffrey and Newman's theories influence a law enforcement mindset hinging on place-based policing. Following the advent of place-based crime theory came the broken windows theory, popularized in a 1982 article in The Atlantic by George Kelling and James Wilson. Kelling and Wilson were fascinated by Philip Zimbardo's 1969 experiment involving two cars, one intact and one derelict, left parked on a street in which the derelict vehicle was soon overrun by, quote, vandals who looted and further destroyed the mobile while leaving the intact vehicle untouched. Furthering this concept, Kelling and Wilson proposed that instead of attempting to curb the tide of major crimes directly, law enforcement should focus their efforts on lessening minor offenses on the community level that could potentially snowball into more rampant forms of illicit activities. Broken windows theory and policy influenced more controversial policing methods, such as stop, question, and frisk policies in New York City, which disproportionately targeted African Americans and Latinos. The 1990s marked the advent of organized crime mapping and police force mobilization using the CompStat computerized statistics managerial system, first implemented by the NYPD in 1994. Based around a specific crime trend, the CompStat system is used to gather data on a given issue, while weekly, monthly, and annual briefings are held to set department-wide benchmarks for reducing the impact of crime in those neighborhoods under the department's jurisdiction. Today, the CompStat system is utilized globally. Predictive policing extends the model set by CompStat as a targeted crime analyzing system. However, what sets predictive policing methods apart is their algorithmic crime data analysis, which permit information gleaned from such analyses to be much more granular and targeted. For example, instead of limiting the resolution of analyses to be set on the order of the neighborhood, algorithmic data analysis allows for the probing of multiple types of crime on the order of a specific city block daily. Currently, predictive policing protocols are outsourced to private startup corporations that market their services to police departments. Available predicting policing methods implement varying strategies to forecast crime and attempt to mitigate bias. For example, HunchLab assumes no initial hypothesis and instead utilizes machine learning protocols to correlate multiple variables, including general crime data as well as weather conditions and the hours of local businesses, to predict time and location of crime that is probable. Depicted here is HunchLab's interface. Each probable area for crime is color-coded based on the type of crime. The HunchLab interface suggests the safest and most effective officer tactic based on crime and available resources of the department. In evaluating the history of policing techniques throughout the 20th century, we see that origins of predictive policing, especially the raw input data of arrest and crime history utilized by these algorithms, may be potentially biased even before any allegedly objective data analysis takes place. We have seen evidence of racial disparities in incarceration versus actual criminal activity time and again, most strikingly in drug-related offenses. Although whites, when compared to blacks, are more likely to use illicit drugs, as seen in the graph on the left, and more likely to be using drugs during a criminal offense, as seen in the graph on the right, the incarceration rate is notably highest among black males. In view of this information, how do crime predicting startups design their protocols to eliminate bias? PredPol, a predictive policing mathematical model authored by UCLA anthropology professor Jeffrey Brantingham, boasts the use of only 3 data points in its algorithm: crime type, crime location, and crime data and time. By limiting its analysis to only these 3 variables, notably excluding personal information, Predpol claims that it circumvents the issue of racial profiling. However, in a non-peer-reviewed study by Christian Lum and William Isaac, Predpol's algorithm revealed its forecasting methods hinged on previously biased location data that disproportionately predicted criminal activity in areas largely populated by people of color in the test city of Oakland, California. The study utilized a synthetic population of Oakland generated from U.S. Census data to accurately reflect demographics on the individual level. Geospatial data based on the synthetic population were analyzed using Predpol's algorithm, one of the few models that has been published by a predictive policing startup. Let's look at the geospatial crime data. On the left is the number of drug arrests in 2010 based on data obtained from the Oakland Police Department, while the figure on the right is the estimated number of drug users by grid square based on the 2011 National Survey on Drug Use and Health. The concentration of arrests in the figure to the left occurred in neighborhoods around West Oakland and International Boulevard, 2 areas with largely non-white and low-income populations. However, estimated drug use in the figure to the right expresses a more evenly distributed trend across the Oakland region. Next, Lum and Isaac ran Predpol's algorithm for the 365 days in the year 2011. The figure shown depicts how many days an area was targeted by the mathematical model suggesting patrol for drug-related crimes. The deeper the color, the more days the quadrant was targeted. Moreover, according to the output of the Predpol algorithm based on crime location, blacks would have been targeted 1.5 times more than whites. Compare this to the statistically non-significant differences in percent drug use between each racial demographic. Based on this study, use of geospatial data based on previous arrests only serves to reinforce biases based on race and socioeconomic status.
Next, we will explore some of the data in bias research as well as the biology associated with it and some of the failures in predictive models that have been used. First, we'll look at implicit biases that negatively impact African Americans. Here are 2 tests that were conducted on white subjects. The first is the implicit association test, which tests for unconscious associations by measuring the delay in time to identify 2 associated items. The shorter the delay, the stronger the association. Note that there is a longer delay when associating black faces with the word good or white faces with the word bad, but there is a shorter delay when associating black faces with bad or white faces with good. This shows that there is an unconscious negative association among the participants. The startle eye blink test uses eye blink activity to measure how these participants are startled when shown white faces or black faces. Here we can see that the white participants are more startled when shown black faces. The researchers also looked at brain activity during the implicit association test and the startle eye blink test and found that higher scores on both tests were correlated with increased activity in the amygdala. The amygdala is a collection of nuclei in the limbic system and is involved in a wide variety of neural functions, including processing fear and anger. Next, we'll explore a bit more about the amygdala and associated regions. In addition to processing fear, the amygdala is known for being involved in defense, aggression, and fleeing responses, and is accompanied by the release of adrenaline and increased heart rate. When activation of the amygdala occurs, there is reduced activity in the prefrontal cortex, which means that there is a reduced ability to inhibit the emotional response. Some examples of diseases associated with amygdala malfunction are Urbach-Wietz syndrome, which results in the calcification of the amygdala and a diminished fear response. Kluver-Bucy syndrome, which is a bilateral medial temporal lobe lesion resulting in various symptoms, including fearlessness, and toxoplasmosis infection in mice, which concentrates infection in the amygdala and reduces the mouse's fear of cats. A study of police officers in Europe, trained specifically for handling high-stress situations, showed that despite training, they could easily become agitated and show aggressive behavior towards the suspects. Police were given 2 scenarios with agitators, either aggressive agitators or non-compliant agitators. In both scenarios, the police officers escalated the situation and even shot the suspects in 37% of cases. The study also revealed an immediate increased heart rate and reduced cognitive control, likely mediated by hypothalamic signals to release catecholamines and reduce cognitive control several minutes after the event occurred, likely mediated by the release of cortisol, a slower stress response. The pitfalls of predictive policing algorithms are well known. In 2016, Chicago employed an algorithm to predict individuals likely involved in shootings, which resulted in millions of dollars spent with no change in crime rates. In 2017, a predictive policing company named Civiscape admitted that police data may be unreliable in developing these models, and they are working to remove these biases in the data, but they still have no clear answer as to how to do so most efficiently. Also in 2017, Taser announced that it would be providing free body cams to police departments and use this video data to predict the probability that an individual will act in some particular fashion. But they do not disclose the details on how they do this, and they do not disclose how they address biases in computer vision algorithms. So, what are the next steps? Although some companies have been working to source for bias, there has been no clear evidence of success. Many civil rights groups are urging police to proceed with caution, as these models are known to target minorities and are not objective like some people suggest they are. A significant issue that has not received as much attention as it should is that several startups working with predictive policing are attempting to obtain individual internet user data as well as social media data to label individuals as high-risk targets, which means that your friend group or Google search history may be used by police to determine if you are likely to engage in criminal activity. There is much more work to be done when building these models, and buzzwords like artificial intelligence, machine learning, and deep learning are being used ubiquitously by several companies to pretend as if they are objective and data-driven, but these methods of building prediction models are still very new, and they are commonly misused and misunderstood, so we must proceed with caution.